Now, in the next question, we have to name the property of multiplication shown in the following. So and I have taken the correct answer in the random order. Now, first one here is this one, that is negative 12 over 5 when multiplied by 3 over 4 results is same as 3 over 4 multiplied by negative 12 over 5. So what you can see that this is just a rearrangement or the change in the order, right? So from here you can see that this is actually written as what? A multiplied by B same as B multiplied by A. And that means it's a commutative law of multiplication, also known as order property. Now we have done the first one over here. First is done. Let's see the second one. In this second part, we have this. That is, we have this. So you can see that a number multiplied by 1 is the number itself. So this is called what? Multiplicative property, right? 1 as the multiplicative identity, 1 being the multiplicative identity. Now looking into the next part, look into this. If I rewrite this, let's say if A multiplied by B multiplied by C, and I can see that here A is outside the bracket and B and C are within the bracket. So clearly this is associative property. And this is associative property for what? Multiplication. Right. So we'll say that this is associative property of multiplication. This one is the correct answer for this. Now, what about this? You can see that this any number multiplied by 0 is 0, right? So this is multiplicative property of 0. And finally, this, let me write down, this is say A multiplied by B plus C is what? We can see that over here, A multiplied by B. So it's A multiplied by B. Well, it should be plus. There is an error in the typing. And plus, that should be A multiplied by C, right? So this is what? Distributive property of multiplication over addition. So this is distributive property of multiplication over addition. So this is the correct answer for this question. The first question is, which of the following is not true? So the first option here is that rational numbers are closed under addition. Well, we should say it's true because on adding any two rational number, we get a rational number. Now the next here is the second option. If I can see that rational numbers are closed under subtraction. This is also true, as when you subtract any two rational number, you get a rational number. And the next is rational numbers are closed under multiplication. So if you multiply any two rational numbers, you will get a rational number. So we should say this is also correct. Now we should know why this would be wrong, because it says that rational numbers are closed under division. So one may say that if I take two rational numbers, say 7 and the other as rational number 5, then 7 divided by 5, which is a rational number. So it should be true. Then why we are considering this to be a false statement? This is because of one such case, like 7 is a rational number and 0 is also a rational number. But when we divide 7 with 0, what do we get? We say it's not defined. So we'll say that rational numbers are not closed under division. Question here says that integers are closed under all mathematical operations except for what? So what we know that on multiplying two integers, we get an integer. On subtracting two integers, we get an integer. But in case of division, there is one such case when we divide any integer by 0, which is an integer only, we don't get an integer, right? This is not an integer. So we'll say that division is one such mathematical operation which is where the integers are not closed. That means integers are not closed in division. As for the question, it should be correct answer is this option, because we have to look for one such mathematical operation where the integers are not closed. So division is the correct answer. Now this question says multiplication of integers. So the first option is both commutative and associative. That is true. That we can say that A multiplied by B in case of integer is same as B multiplied by A. Same for the associative in case of multiplication, right? A multiplied by B multiplied by C is same as A multiplied by B multiplied by C. So it is true. Now is commutative only will be wrong and associative only will also be wrong. Neither commutative nor associative is wrong, as we can see that it is both commutative as well as associative. The question here is the reciprocal of any natural number. So let's say if I take the smallest natural number, its reciprocal is what? The number itself, which is 1. And if I take let's say a big number, let's say if I write 107, its reciprocal is what? 1 over 107, which is what? A proper fraction. It should lie between 0 to 1. Now, here we can say that for any natural number, right? Any natural number, their reciprocal will be either 1, right? We are talking about the reciprocal as can be 1 or lesser than 1 but more than 0. So we can say that it should be more than 0 but can be equal to 1 or lesser than 1. So as for we can say the nearest option will be 0 to 1. But here we should know that 1 should be included, as we know that the reciprocal of a natural number, 1 being a natural number and its reciprocal is 1. Right. For others other than 1, they all lie between 0 to 1, and for 1, the reciprocal is 1 itself. Question here is dash is the only rational number which does not have a reciprocal. So we know that 1 reciprocal of 1 is 1, reciprocal of minus 1 is 1, right? But what is the reciprocal of 0? That's not defined, right? 0 is 0 over 1, but when we reciprocate it, it is 1 over 0. That is not defined. So we say that the 0 does not have a reciprocal. So that as for the option, this is the correct option. Next question say which of the following statement is incorrect? The first one is multiplicative identity of integer is 1. So that is 1 multiplied by any integer or any integer multiplied by 1 is the integer itself. So we'll say it is true. Next it says subtraction does not obey the commutative integer. Like commutative a minus b is not equal to b minus a, as you know, right? Like 7 minus 10 is not equal to 10 minus 7. As you know, 7 minus 10 is what? It is minus 3, and 10 minus 7 is 3. So they are not equal. So we'll say that this is a correct statement that subtraction does not obey the commutativity in integers. Now coming to the next here, it says as for the next is multiplication of two integers with unlike sign is always positive. So unlike sign is what? We can say that for unlike sign, let's take an example. So I took 7 minus 7, right? Negative 7 with unlike sign. That means if I multiply this, right, with say positive 10, what we are getting here as negative 70, right? So multiplication of two integers with unlike sign, we are getting negative, not a positive. So let's say if I multiply a with another integer which is negative, or I should take an example, let's say 10, and I multiply it with minus 5, that results to give you minus negative 50 here, right? So multiplication of two integers with unlike sign is not positive, right? It should be negative. So this is an incorrect. Well, we can read the other option also. The inverse, multiplicative inverse of a is 1 by a. Yeah. For a, if I say it's multiplicative inverse, it's reciprocal 1 by a. But the condition here is that a should not be 0. As you know, 0 does not have its reciprocal. Is when a positive integer is divided by its additive inverse. Let's say if I take any positive integer, let's say I took 6, and I'm going to divide it by its additive inverse. Additive inverse of 6 is what? Minus 6. So if I reduce, we get negative 1. Now I take any other, let's say if I take 69 and if I divide it by its additive inverse, that is negative 69, that results to give you what? Minus 1. So irrespective, whatever is that positive integer, how big or how small it is, if you divide it with its additive inverse, that results to give you what? Minus 1. So we'll say that This -1 is the correct option. Now we are given here expression where -4/5 that added with the results of addition of this, and in the other side we have the sum of this when added with this. So it is true, like we have to identify the property. Well, by looking into the brackets, most of you judge it that this is distributive property. You write this, which is a wrong answer, right? This is not correct. Now check here, if I take this as A, this as B, this as C, what you can observe from here that this is A added with the sum of B plus C. And on the other side, we can say that over here, A plus B added with C. So clearly this is associative property, right? So associative is correct and not distributive. Question says, which integer is obtained by additive inverse of -53 to the additive inverse of 35? So we have to, which integer is obtained by adding, right? So we are going to add the additive inverse of this. So what is additive inverse of -53? It should be +53. And I have to add the additive inverse of +35, which is -35. So this is 53 plus minus is minus. So it's going to be 53, right? So we are going to subtract here. That is subtracting 35 with 53. It should give you 18. So we'll say that this is the correct answer. And here we have to find whether these statements are true or false. The first one is what? 0 is the smallest. 0 is the smallest rational number. No, rational number can be negative also. So we'll say that it is a false statement. Now the next one is every rational number is a whole number. Yeah, we know that no, every rational number is not a whole number. As 7/2 is a rational number, but this is not a whole number, right? So we'll say that this is again a false statement. Every rational number is not a whole number. So know that every rational number is not a whole number. Next is, it says they are equivalent. 4/3 on reducing will not get 2/3. So this is also false. So we'll say that this is also false. Now coming to the next one, two rational numbers with different numerators. Two rational numbers with different numerators can never be equal. Now check here, we need different numerator. Let's say 7/2, and the next I'm writing here as 14/4, right? We have a different numerator as you can see, but they are equal, right? You can see that on reducing, we are getting 7/2. So we'll say that this is a false statement. So as of now, we get all of them as false. The next one here is every rational number, every fraction is a rational number. Yes, you should know that. Rational numbers include fractions, decimals, whole numbers, integers, and all. So we'll say that, yeah, this is a true statement. Now, the next one, if I see, the next is the quotient of a two rational number is always a rational number. That means on dividing two rational numbers, we should always get a rational number. Well, ordinarily it is true, but except for 0. Like 7 is a rational number, 0 is a rational number. On dividing this, the quotient, which is not a rational number, as you know. So we'll say that this is again a false statement. The decimals, all decimals are rational number. Yes, as I said that decimals, fraction, integers, they are all types of rational number. The sum of two rational number, the next one. Sum of two rational number is always a rational number. Yes. When you add any two rational number, we always get a rational number. Okay, as I proceed to the next one, it says this one. In a rational number, denominator always has to be non-zero. Yes, any rational number, the denominator must be non-zero. It cannot be zero, right? Because on zero, it is not defined. Right, moving to the next, the last one here is, it says 0 is a rational number. Yes, because 0 can be written as 0 over 1. So any number which can be written in the form of p by q, where q should not be 0, is a rational number. The question is, how many pieces of tape this centimeter long can be cut from a tape which is 1 meter 75 centimeter? So let's say I make a tape. Let's say I took one tape. So this is the total length of the tape. And this is how much. If I write this in centimeter, it's going to be 1 meter 75 centimeter is same as, it should be 175 centimeter. So here we know the total length of the tape, right? We know the length of the tape as this. Now we can see that we have to cut them into small pieces, right? These are to be cut into small pieces. And then the question here is, each piece has to be how much? This is each piece, as you can see over here, is 3/7 over 5, right? This is 3/7 over 5. On reducing this into improper fraction, right? This is 7 into 3 is how much? 21 plus 4, that's 25 over 7 centimeter. So each piece is 25 over 7 centimeter, right? Each of them 25 over 7 centimeter. We have to find the number of pieces. So what we can see that, let's say the number of pieces is n multiplied by the length of one piece should give you the total length, which is 175 centimeter. So in order to get n, we are going to transpose this number to the other side. So it should result to give you multiplied by 7 and divided by 25. It is reducible. This is 7 times, right? It should be 7 times. So we, from here we get n as what? 7 multiplied by 7, which is 49. So we'll say that 49 such pieces can be, 49 pieces of length, this can be cut from a ribbon which is 175 centimeter long. Here the question is, what should be added to this to get 4? So the first thing we are going to do is to simplify this to get a single rational number. So for that we have to take the LCM, and LCM of 2, 3 and 5 is what? It is 20. Oh, sorry, it's not 20. It should be divisible by, these are three prime numbers, right? They are co-prime, so it will be 30. Now I'm going to simplify this, and for that I'll be multiplying this with 15 to make it, yeah, this is 15 over 30. This I have to make 30 as the denominator, so we'll be multiplying with 10, so it's 10 over 30. And this, when multiplied by 6, is 6 over 30. So on simplifying, we get how much? This is 10 plus 15 is 25, and with added with 6 will result to give you 31 over 30, right? So we added this. Now question is, what should be added to this? The question here is, what should be added to this number? So this number is same as 31 over 30. What should be added to this so as to get 4? So clearly, in order to get x, I need to transpose this to the other side, so to give you 31 over 30. This can be simplified by multiplying with 30. So it's give you how much? This is 120 over 30 minus 31, right? This is 31 over 30. This is how we will get. So now first we are going to subtract 31 from this. So it's going to be 89. And this is 89 over 30 is the required answer for this. In this question, you see there is a water pipe as shown in the diagram. This is a water pipe, right? And whose diameter is given. So this diameter, this is the diameter, right, of the pipe. So we know this length. Let me write it down. So we can write down this diameter as how much? 3. 3 by 4 can be reduced as what? This is 4 into 3 is 12. 12 plus 3 is 15. So it's 15 over 4 is what? The inside diameter we know. And further it says that wall thickness of the wall is this, right? So thickness of the wall, I can show you one second. So I can see from here the thickness of this wall is going to be this, right? This is the thickness of the wall over here. And its thickness is represented by a number, and that is how much? This is 5 over 7. Yeah, this is the thickness. Let me highlight in the one. This is the thickness over here. So now question is, what is the outside radius? Outside radius, let me once again show you. This is what the inside radius, right? This is the inside radius, and outside radius is going to be this. So from here you can see that if I add the thickness, if we add the thickness with the inside radius, we'll get the outside radius. So that means we need to first find out the inside radius, which I'm using small letter r to denote it. It should be half of this, right? Half the diameter is the radius. So half multiplied by the diameter, which is how much? 15 over 4 is the inside radius, that is 15 over 8 centimeter. And as I said, if I add the thickness over it, right, that will should give you the outside radius. So the outside radius will be the inside radius, which is this, and then we are going to add what? The thickness, which is 5 over 7 as per the question. So rest is taking LCM, which is 8 into 7, that is 56. And we should know that 15 multiplied by 7, right? So is 105, and 8 multiplied by 5, that is 40. So it should give you 145, right? 145 over 56 centimeter. So we can write them in the mixed fraction. So that should be the answer, right? If it's better if you write down the answer in the mixed fraction. In this question, it says area of a parallelogram is 12 1 over 4 centimeter square, and yeah, and then what we have else? We have its height given as this. What we have to find out is the base. So for that, we need to remember the formula for parallelograms. The first thing that I'll do is to make a parallelogram. Just to understand it. Okay, so this is not an exact shape of a parallelogram. Let me try one more time. Two pairs of opposite sides should be equal. Yeah, seems to be better. So here we know that the altitude is what? The distance between the parallel side is called the altitude, right? So, and base can be any one of them. That's uh, by by that I mean to say, if I name it A, B, C, D, it can be either A, B, or C, D. They say AM is the altitude. So this is H over here, say base, the height, and this being the base over here. So what we know that area of a parallelogram, a formula for area of a parallelogram is, say A is the area, is base multiplied by the altitude, altitude or height. So we know the area here and how much it is. This is, you can see here, this is 12 into 4 is 48. 48 plus 1, that is 49. So we can say that we have the area here as 49 over 4, right? And the height is given and the base is missing. So let's represent base as B only. So this is how much? 7 into 1 is 7 plus 6, that is 13 over 7. Right. So we got this. Now what we have to do is to find out the base. So what we are going to do is to transpose this number to the left hand side. So it is 49 over 4, that multiplied by 7 over 13 should result to give you the base. One more time. Here we know the area of the parallelogram as this, which is 12 1 by 4 is how much? Same as 49 over 4. And the base is what missing over here, and the altitude or the height is given as this, which is 13 over 7. Now in order to get base, we are going to transpose it to the left hand side, and as we transpose it, what happens? This number will get reciprocated on transposing. That's why I multiplied this by 49 by 4 multiplied by 7 by 3 should give you the base. Now this cannot be reduced, as I can see, then we have to multiply this. So we'll finally say base as how much? That is 49 multiplied by 7. That is a cube of 7, which is 343. And then 13 into 4 is how much? 52. So we'll say that this is what the measurement of the base in this case. In this question, we have to find the reciprocal of this. And what is this? This is modulus, right? So first of all, if I write modulus or absolute value of a number is the same number, with positive sign, right? So we'll say that we are not just, as of now, I've just written this in the simplified form. That's without modulus. And its reciprocal will be what? The reciprocal of a number is what? Flipping the order. That is, I mean, not order, the numerator and denominator reciprocating. So 9 over 7 should be the correct answer. That's positive 9 over 7, right? Because as I said, the moment we remove this modulus sign, the inside sign will become positive. And that's how we got this. The question says concert tickets usually cost rupees 124 over 3 for per person. That's the normal cost. For student, they are priced one fourth of the normal cost. And our final answer question is how much will 6 tickets cost for? Right, 6 tickets for student. That means we have to get the price of 6 tickets. So what we are going to do in the first go is to find the cost of one ticket for a student. So it's going to be what? It is one fourth of the normal cost, and normal cost in improper fraction, it is how much? 12 into 5 is 60, 64. That means 604 over 5. This can be reduced, right? That's 151. It should be, right? Because 604, if I divide it by 4, should result to give you 151. So this is the cost of one ticket for a student. But then we have to get the cost of 6 tickets. So we know the cost of one ticket. So 6 tickets will be what? 6 multiplied by this value. That is 3, 2 times, sorry, 2, 3 times, and 2, 2 times. So if I multiply this by 3, it's how much? This is 3, 15, 453 divided by 2. So we have to get the cost in rupees. So we should divide it, right? Convert in decimal. So it should give you rupees 226.50. So that should be the answer for this part. It says if 1 over 3 of a number exceeds its 2 by 7 by 1. So let's say if I take the number as x, right? So let's first find out one third of this number. So one third of a number is what? X over 3. And exceeds is 2 7. So what is the 2 seventh of a number? It has to be 2x by 7 by 1. So which is bigger? This one third is exceeds the 2 7. So obviously the difference always comes from the bigger, as you know, this is bigger than this. So the bigger minus smaller, and the difference is given as 1. Right. Rest we are going to simplify it. Now the LCM is how much? 21. So 7x times is 7x minus 3, 2x. 3 multiplied by 2x is what? 6x is equal to 1. So this is 7x minus 6x is 1x, which is x only. So x over 21 is equal to 1. On transposing 21 to the other side, it's 1 multiplied by 21. So that is 21. So the required number is 21. So you can even verify this. When you find the one third of this number, you are getting one third of 21 is 7, and 2 seventh of this, 2 seventh of this. So that is coming as, so if you multiply this, what you're going to get here as 6, right? So clearly 7 minus 6 is 1. Well, verification is not needed for this working. We have to find the number, and the required number is 21. Now, the question here is which of the following properties is used over here? That is 0 plus a plus 0 equals 0 plus a is equal to a. Now, I've seen that many of you actually use this property, that commutative. This is not commutative, as here a plus b is not equal to b plus a, right? The result here is 0. So what we know, when 0 is added to any number, or any number added with 0, is the number itself is what? Is the additive property, right? Is an additive property. That means 0 is an additive identity. That's why we say it's a additive property. So this is not correct, right? These are definitely not correct. So confusion comes between these two. It's not a commutative property. Instead, it is additive. Over here, the question is the rational number that is equal to its reciprocal, right? So most of you end up just writing 1 because the reciprocal of 1 is what? 1 over 1, and that is equal to 1 only. But don't you see that this is not number, this is numbers. There are more than one. So in fact, 1 and minus 1. The reciprocal of minus 1 is also minus 1, right? So it should be, our final answer should be 1 and minus 1 are two such numbers or two such rational numbers which are reciprocal to itself, which is equal to its reciprocal. Well, in this MCQ, it says on multiplying 5 over 3 with what? So we have to fill this space, right? With a number so as to give the multiplicative identity of a rational number. So what is multiplicative identity of a rational number? It is what? 1. So what we have to actually find out is 4 over 5 multiplied by what should result to give you multiplicative identity, that is 1. So what we know that when a number is multiplied with its reciprocal, when a number is multiplied with its reciprocal, we get 1. So we need to look for one which is reciprocal of this. So definitely these are not its reciprocal, and 5 by 4. You may justify also by multiplying this with 5 by 4. So you can see that they get cancelled to give you 1. Well, in this question says, which of the following is not, right? You have to keep in mind it is not the additive inverse of A. So what is additive inverse of A? First of all, we should know that additive inverse of a number is the same number with opposite sign, right? Now, before we judge the answer, let's first simplify them. So what is this is equal to? So you can see from here, this is minus into minus is plus. So this is positive A. We're not judging the answer as of now. This is give you A multiplied by negative 1 is negative A. This is negative A itself. And A multiplied by negative 1 is negative A. Now question over here is which of them is not the additive inverse? So not is the answer. So we can say these are yes, right? And not is what? This. So we'll say that as for the question, it should be this option, right? The correct option, when it comes to correct option, we should say, because we have to look for not, right? We have to look for not an additive inverse. So therefore, A is not an additive inverse of A. It is the number itself. Now in this question, it says what should be subtracted from negative 5 by 3 to get 5 by 6. So what we are going to do here is to take the number as say x. So over here I have taken let x be subtracted, or the required number is x. So we are going to subtract x from this number, that is negative 5 over 3, and subtracting, as I said, we are going to subtract x over here should result to give you what? 5 over 6. Now, as I said, we should make the variable positive. So I should transpose this on the right hand side. So it should become positive x. On the left hand side, we have negative 5 over 3. On transposing this to the left hand side, will become negative 5 by 6. Now, next, what we are going to do is to take LCM. And for that, we have to make that denominator same. Over here, we'll be multiplying with 2. That results to give you what? Negative 10 over 6 and minus 5 over 6 is equal to the required number here, which is x in this case. So on simplification, what we'll get over here, this is negative 15 over 6 is what we'll get from here, which is equal to x. On reducing 3 2 times, 3 5 times, so we can say the required number x is negative 5 over 2. In the next question, it says, what should be added to 7 over 12 to get negative 4 over 15? So what we are going to do here is to take the number or the required number as x. So here what you can see that from on 7 over 12, right? What should be added? So we said that we are going to add x over here. So we can say that 7 over 12 When x is added to this, results to give you what? Negative 4 over 15. So what you can observe over here, that required number x is already positive. So we are not going to transpose x. Instead, we'll be transposing 7 over 12 to the other side. So it should become minus 7 over 12. Now we'll take LCM. The LCM is how much? For 12, 15 is 60. So 15 4 times, and 4 into 4 is 16. So it's minus 16. And 12 5 times is 60. That will 7 multiplied by 5 is how much? 35. So now we have x as how? That is the sum of this 16 and 35, which is negative 51, as both of them are negative, divided by 60. Now what I can see, they can be reduced by 3, right? So 51 is divisible by 3, that is negative 17 times, and this is 20. So we'll say that this is the required number that should be added. Now in the next question, it says that the product of two rational number is negative 28 over 81. If one of the number is 14 over 27, then the other number. So we will take the other number as, say, x in this case. So if I take the other number as x, so what we can say, that when x is multiplied with this, that is one of these number, 14 over 27, that results to give you the product as how much? Minus 28 over 81. Now we are going to transpose this to the other side. So you should know that on transposing, it will be multiplied. On the other side, it should be multiplied by the reciprocal of this. So it should be 27 over 14. Now you can see that it can be reduced by, well, if you know, that is 27 3 times is this, and 14 2 times is this. So that results to give you x, and x is negative 2 over 3. So we'll say that this is the required answer. The next question is the multiplicative inverse of a negative rational number. So what do we know? That let's say if I talk about any rational number, a over b, where b is not equal to 0, or you may take it like this. Let's say take an example, 7 over 9, right? This is a rational number. And when we talk about a negative rational number, it should be a minus. Now we are looking for its multiplicative inverse. So how do we get a multiplicative inverse? That's also called reciprocal. On reciprocating this, we'll get what? 9 over 7. We generally write minus in the numerator. Now, what's our conclusion here? That on reciprocating a negative rational number, we get a negative rational only and not a positive. So we'll say that, we should say that the multiplicative inverse of a negative rational number is negative rational number. The next question says 0 is what? Is the identity for addition of rational number, identity for subtraction of rational number, identity for multiplication of a rational number, or identity for division. So what you should know, that if you multiply 0 with any number, we don't get the same number, right? We get in fact a 0. So therefore 0 is not the identity for multiplication. You should know that it is not the identity for multiplication. Now therefore, look for some other things, like if I add 0 with 7, or maybe 7 with 0, what do we get? We get 7 only. So we say that 0 is the additive identity, or we may say that identity of addition. That's also called additive identity. So we should know that 0 is called the additive identity. In fact, 1 is called the multiplicative identity, because 1 multiplied by any number, say a, or a multiplied by any number, say 1, results to give you a. Therefore, we should say that 1 is a multiplicative identity and 0 is an additive identity. The next question over here, it says the multiplicative inverse of minus 1 over 7 is. Now what we need to do here is to first convert this into improper fraction. Well, this is in mixed fraction. So ignoring the minus sign, or keeping the minus sign outside only, 7 into 1 is 7. 7 plus 1 is 8. So it's 8 over 7. Make sure you do not consider this sign over here, right? Sign is outside, should be taken. Now we know this is what can be written in the improper fraction, and if you have to find out the multiplicative inverse, what we do? We reciprocate this. So on reciprocating this, minus will keep in the numerator is minus 7 over 8. Yeah, so minus 7 over 8, which can also be written as 7 over minus 8. So we'll say that D is the correct option. The next question here is, it says subtract the additive inverse of this from the multiplicative inverse of this. So let's figure out what is the additive inverse. What is the additive inverse of 5 over 6? So additive inverse of a number is what? The same number with opposite sign. So it's going to be minus 5 over 6. And then we have to find the multiplicative inverse and multiplicative inverse of this. But before we find its multiplicative inverse, let's reduce it. We can see that 7 1 times, 7 2 times, 5 1 times, 5 3 times. So it is the same number. This is the number after reducing is what? Negative 2 over 3. But then we have to find its multiplicative inverse, and its multiplicative inverse should give you what? Its multiplicative inverse should give you negative 3 over 2. As you know that multiplicative inverse is reciprocal of this number. Now we have to subtract. We have to subtract this from this. So that means we need to write negative 3 over 2, giving a minus sign for subtraction and writing the other number, which is negative 5 over 6. And on opening the bracket, on opening this bracket, these two signs will interact to give you a positive sign. It's positive 5 over 6. Now next, to simplify, we are going to make the same denominator. For that, I'm going to multiply this by 3. That results to give you minus, that is negative 9 over 6 and positive 5 over 6. So minus 9, that is negative 9 plus 5 should give you negative 4, that divided by 6. Yes, we can simplify it further by reducing with 2 2 times and 2 3 times. So it's negative 2 over 3 should be the answer for this part. And in this question, it says the product of a rational number minus 2 by 3 and its additive inverse is what? So what we can say that we have a number that is minus 2 over 3 and we have to find the product. So we'll say multiply with its additive inverse. So what we know, the additive inverse of a number is same number with its opposite sign. So it's minus 2 over 3, same number, right? It should be same number but with opposite sign. So it should be positive 2 over 3. Now if I multiply, this is minus 2 into, this is negative 2 into 4, right? So 2 into 2 is what? 4, 4 divided by 9. So we'll say my negative 4 by 3. So negative 4 by 3. So 4 by 9 is the correct option in this case. The next question says, what should be subtracted from negative 2 by 3 to get negative 1 over 6? So question is, what should be subtracted from this? So if I consider this any number, say x, I say, let's say x be subtracted. You see, I'm subtracting x from this number, and that results to give you negative 1 over 6. So we have to determine the value of this x and not negative x. Now, what I suggest all students that always try to make the variable as positive, either on transposing from left to right or maybe right to left. So I'm going to transpose this to the right hand side and this to the left hand side. So as you know that, let's say I write this first and I'm going to transpose this to the left hand side. So it's going to be, as you know that on reciprocating on this side, it will change the sign. That means now it's going to be positive 1 over 6. And this on transposing to the right hand side should give you positive x. Now, what next? We are going to make the same denominators. For that, I have to make multiply by 2. Yes. So this results to give you what? Negative 4 over 6 plus 1 over 6. And that should be the value of the x. So this is negative 4 plus 1, right? Should give you negative 3, right? This is negative 3 over 6 equals x, which can be reduced as what? 3 1 times, 3 2 times. So we can say x is equal to negative 1 over 2. That should be the answer for this. Now this one is important. It says by what number should this be divided so as right, should be divided to get negative 11 over 2. So same as the previous case, here also we are going to take, let's say, negative 33 by 8. Let's say this divided by, I took a number as say x, right? So as the resultant number is 11 over 2. Now, do not transpose this number, right? Instead, transpose x on the other side. So what you are going to do is, since it is divided on the left-hand side, it should be multiplied on the right-hand side. So I should be multiplying this by x over here. And in the next step, I'm going to transpose this to the left-hand side, right? This will isolate x. So this is negative 33 over 8. On transposing this to the other side, it should be multiplied with its reciprocal, right? You should know that on transposing, right, whenever we transpose a number which has a product relation on the other side, it should be multiplied with its reciprocal. Check here, this minus and these two minus get cancelled. This is 11 one times, 11 three times, 2 one times, and 2 four times. So what we are getting over here is x is equal to 3 over 4. So this will be the required number. The question here is the product of two rational number is this. And if one rational number is minus 4 over 3, find the other. So we know that we know the first number as one of them is minus negative 4 over 3. And I'm going to take the other number as say x, so that their product is this, that is negative 16 over 9. Now, in order to determine the value of this variable x, we need to isolate it. And for that, I'm going to transpose this to the other side. So it's going to be x. We know that on transposing this whole thing, right? I'm going to transpose this whole thing. It has a plus multiply relation with this. It has a multiply relation with this. So on the other side, it should be divided. But you should remember that it's not going to change its sign, as we should see that there's a product relation with this. So on the other side, it should be divided with the same sign. So this is x is equal to negative 16 over 9, and dividing is what? Multiplying with the reciprocal. So it's going to be 3 over negative 4. Now this can be reduced. We can reduce this 3 one times, 3 three times. These minus get cancelled. 4 one times, 4 four times. So therefore, x comes out to be what? 4 into 1. 4 multiplied by 1 is 4, and 3 multiplied by 1 is 3. So it's 4 over 3 is the answer for this. So in this word problem, it says a rope which is 11-meter long, two pieces of length, 2 3 by 5 meter and 3 by 10 meter are cut. And what we have to find out is the length of what is the length of the remaining rope. So what you can see that, let's say if I take this as the rope, I may take here. So I took this as the total length of the rope, and I'm going to cut it into 3 equal parts. Let's say I cut it as 1, and let's say this be the other part. So we can see from the question that we know 3 parts. First of all, we should write down the total length. Well, total length, that's from here to here, right? The total length is 11 meters. So this is 11 meter. And it has 3 divisions. One is this, second is this, and third is this. The third is this. Now the length of the first fragment is given, that is 2 3 over 5. That of the second is also given, that is 3 3 over 10. And we have to determine the length of the last one. We have to determine the length of this. So for that, what we are going to do is to consider this length to be x. Consider this to be x, right? So what you can say that the sum of these three, that is say x in any order, if you add plus 3 3 over 10 plus 2 3 over 5 should result to give you the total length, which is 11. Now I'm going to simplify this. So this is how much in the mixed fraction, in the improper fraction, is going to be 33 over 10 This is going to be what? This is 5 into 2, that is 10, right? Plus 3, this is 13 over 5 is equal to 11. Now, what we are going to do is to add these two first. So let's say I do it on the other side. This is x plus, so we have to make the same denominator. For that, I'm going to multiply this by 2 by 2. So that results to give you how much? This is 33 over 10 plus 13 into 2, that is 26 over 10. And on the other side, it is 11. So on adding this to what I'm getting, 33 plus 26. So this is 9 and this is 5. 59 over 10 is equal to, this is 11. Next, I'm going to transpose this to the right hand side. So it should give you what? 11 minus 59 over 10. So x comes out to be how much? If I multiply this by 10, it's going to be 110 over 10, right? Minus 59 over 10. Right. So here I took LCM, and after taking LCM, that is 10, we got 110. So now we have to subtract 59. So we'll be subtracting 59 from 110. That is what? 51 over 10. So this is this much measured, which can be written in the mixed fraction as what? 5, 1 over 10 meter. So we can say that this is what? The length of x, or we may say this is the length of the remaining portion.